This is a very team-oriented type project. It's not doing one particular innovation. The Expandable Structures team started around the turn of the year as one of the Langley Innovation Opportunities teams. And it's primarily a team that's re-educating ourselves in this area. There's been a lot of work, not all of it at Langley, but quite a bit at Langley since the 1960s. So we're renewing acquaintances with people in industry and academia. And we're also having people here at Langley that are working on particularly interesting projects present to the team. So it's bringing a whole host of people together to start maturing certain areas. So we have, I said, 40 people. It covers over 10 different branches and 3 different directorates. The advantage of an expandable system, the main advantage is that you can put larger spacecraft inside existing rockets. This chart, shows 4 different categories, and down here there's probably 20 different types of systems listed. So I mentioned the apertures, but we have things like solar sails and space power systems, inflatable habitats. These would be inflatable radio frequency reflectors that are circular, entry, descent, and landing systems, airbags that would land on the moon and have already landed on the moon. And then there's a whole class of other systems that are aerodynamic or aeronautics in nature. Morphing systems, large, long endurance aircraft that might take off in a smaller state, and when they get to operating conditions, they could expand to much larger so they could stay aloft longer. So primarily we're looking at space systems, but there are a lot of opportunities as well in the aeronautics side. We hired the NIA, Professor Martin Miklas in particular. He's been in the field for 50 years. He's worked exactly in this area. He was the branch head of the Space Concepts branch. We have him under contract to do educational briefings to us. Another thing we did with the funds was to pay for 4 students. We had 2 students last summer develop a database for us. We also have 2 other students now working with us. One's working on inflatable habitats as part of an academic competition for Johnson, and the other one's working on solar sails. So we traveled. We went several trips with oftentimes 4 or 5 people on the team. We've gone to Harris Corporation to see large antennas. We've gone to the West Coast to visit JPL, to visit Northrop Grumman to see some of their systems like the James Webb Telescope, Sunshield. We do 2 things at our meetings. One is we're learning the state of the art in this area. We actually wrote a white paper about 30 pages long, and it specifically has 7 innovation areas that we uncovered. Quite a few are related to materials and how you might use carbon nanotubes or it's boron nitride nanotubes, how you make very lightweight systems with modern materials. Other concepts, for example, on how you maintain a structure to be rigid after you take away inflation. Some of these systems, not all of them, but a lot of them are inflatable. And there's also a question if the gas leaks out, what happens? So some people are looking at innovations to keep the shape even if the gas pressure goes away.